Hello everyone and welcome to the 5th video in the series. This time you'll learn how to make a basic wing using the loft method. In this case we'll create the wing of the A6M, which is the designation for the Japanese Zero fighter. For those who know me, I'm sorry but I couldn't resist including one of my personally favorite airplanes, as you can see here. Anyway, let's get started. Whenever you are creating a wing, being for the purpose of an aerodynamic model, or to include the skin of the wing into an assembly, the first thing you'll need is aerofoil data, such as coordinates, reference distances, dihedral or anhedral angles, and also the amount of washout present in the wing. As for some basic reverse engineering, for let's say a conceptual design, or for a model you'd like, such as the rough model that was made of the Renard R36, a basic cross-section is enough to get the outline of the airfoil. To start off, let's take a look at the documentation, as you can see here. These are the cross-sections of the A6M0's wing. With that, we also have a chart that gives us some more information about the washout. Here you can see the chart of the washout, and you can clearly see how it goes at wing section 12 to wing section 26. Goes from 2 degrees to about minus 0.5 degrees in angle of incidence. Washout is a geometry layout where the angle of incidence at the root is greater than at the tips, thus ensuring lower lift generation at the tip compared to the rest of the wing. This can cause smaller wing tip vortices, but most importantly it ensures that the root of the wing stalls before the wing tips, thus providing aileron control and increasing the chances of getting out of the stall. Next to that, it also reduces the lift-induced drag and can thus save on fuel consumption. With the sketches, we can create different Excel files to import into Fusion 360. As you can see, these are the 4 Excel files that were constructed from the dimensions given on the different drawings. As you will see, the airfoils will be pretty rough, but you can fix this by defining more points on your aerofoil. As I'm using coordinates from drawings where the designer already incorporated the inclination into the coordinate system, it won't be necessary to rotate the airfoil sections. In case you want to do this, you can simply search your sketch, edit it, go to the Modify tab and select Move. Here you can move or rotate your sketch under the desired angle. Let's get back to the wing of the A6M0. So once you have created your Excel files and saved them under the .csv file format, you can go to Fusion 360, press Tools, Add-ins, Import Spline CSV, and make sure that your Excel file values are written in centimeters. Now you can simply import all of your aerofoil files, as you can see here. Once all your splines are imported, you can connect them using the solid feature located in the Create drop down menu and then select Loft. Now you can select the surfaces that you want to connect using a smooth transition. Now we have done that, let's take a look at the rough model of the Renard R36 that we made for our posters. And it can serve as an example of what you should be able to create after this tutorial series. Let's start the replay in our timeline, and now make sure to watch closely, as you will see that in this zone I also drew the outline of the wing. I did this so that they can be used as guide rails. After having played a timeline, we will create a quick example and show you how you can use rails for creating more complex loftings. Now that you have seen how guide rails can be used in a practical example, let's show you how you can add guide rails and what the benefit is of using these. So now we've created a new project. Go to add-ins, and for this case let's just import our spline.csv that we've used before. So let's take the root and let's just take the tip profile as well. In this case we're not going to use the two middle wing rib sections. So we've got our root and our wingtip, and now we will create some new sketches that will serve as the guide rails. But now we will go into 3D sketching mode. So when you create a sketch, select a surface and then go to 3D sketch and select the box, so that you can go into 3D sketching mode. And as you can see now you can create sketches three-dimensionally. So you can just select the point at which you want to start your line, and then select the point at which you want to end. And then you can do the same at the trailing edge. And once it's created, let's finish the sketch. Go to create our loft, select our wing root and our wing tip. Now it will just create a smooth transition, but as you can see it doesn't align with the guide rails that we've made. So then you can just go to guide and then select your rails, and as you will see it will try to deform your structure so that it fits in between the rails. And when you've selected both of them, as you can see here, your structure follows these guide rails, so it can be used for creating some complex shapes. Of course, in this case it's just a straight taper from the root to the tip, but as we'll show you in a different example, you can also create arcs. So going back into 3D sketching mode, let's select a 3-point arc and go from the root to the tip. And once you're satisfied with the curve that you have created, you can again go to Loft, select the both surfaces that you want to connect, and select your guide rails. And as you can see, now you can create these weird wing shapes with this arc in the trailing edge. So that's all possible using lofts, and you can have lots of rails, like especially when you're building fuselages. It will be useful to create this complex shape of your fuselage, because it curves on the top, it curves on the sides, and it can have a totally different curve on the bottom. So that is really useful for creating those complex shapes. Then to finish off, let's show you how you can insert a decal or an image into your sketch. For instance, if you're going to reverse engineer an aircraft into your design, then you can just go to Insert and then choose for Insert Imagery, and then go search on your computer for the imagery and then insert it. And if you will now create a sketch, let's just turn off the 3D sketching mode, return to our sketch, then you can use it as a guide for creating your basic shapes or creating the curves that you will need. So as you might have seen with the Renard R36, we had 3 views of it. So we had a front view, side view, and a top view, and that was used to create the outline of the curves. That was then used for as the guidelines for creating the fuselage. So that might be useful when you choose to reverse engineer an aircraft, or you just want to create a 3D model of let's say in this case of a zero, then you can use it as a guide for drawing your lines. I hope you all enjoyed the video, and next time we will be looking at how you can create a rocket engine. Just to give you a quick example, this is the rocket engine that was created for the EUROAVIA reusable rocket, and this is the assembly, as you can see. So next time you will learn how you can create the basic rocket nozzle that you can see here. Okay, so stay tuned in, and see you next time. Goodbye, have a good day.